Welcome to section 21.8. This is the 216th session of the CISSP exam prep series. In this session, we'll close the loop with the secure coding habits that prevent the flaws we've studied. We'll answer several questions. Why can source code comments become a liability? How does good error handling protect an application? What is wrong with hard-coded credentials? What risks come with AI-assisted coding? And how does poor memory management undermine security? Why does this matter beyond the exam? Because the same handful of coding mistakes keep resurfacing no matter the language or framework. Picture yourself mentoring developers at a rapidly scaling startup. The frameworks change, the team grows, but sloppy comments, weak error handling, and leaked credentials show up again and again. Instilling these habits is how you stop tomorrow's breach at the keyboard, long before it reaches production. Why can source code comments become a liability? Comments are genuinely valuable, documenting design choices and helping the next developer understand the code. The problem is when they end up in the wrong hands. A comment can hand an attacker a roadmap of how the code works, and sometimes it even contains secrets that should never be exposed. For compiled programs, this is less of a worry, since the compiler strips comments out automatically. But web applications can expose their source directly, letting outsiders read every note left behind. The rule is simple. Keep comments in your archive source for future developers, but remove them from anything published to the internet. Picture leaving detailed renovation blueprints taped to the front door of the building. How does good error handling protect an application? Attackers deliberately push code into strange situations to see how it breaks, so your code must expect the unexpected. It is not enough to confirm that a field holds an integer, because someone might paste a 50,000-digit number to trigger an overflow. Many languages offer try-and-catch structures, where risky code sits in a try block and the catch block defines exactly how to respond when it fails. Crucially, error handling is a second layer behind input validation, catching anything your validation missed, which is defense in depth in action. But there is a flip side. Overly detailed error messages can leak the inner workings of your code and invite attack. The guideline is to show users only the minimum they need, while logging the full details privately for your developers. Think of a receptionist who politely says there was a problem, while the full incident report goes quietly to the back office. What is wrong with hard-coded credentials? Baking usernames and passwords directly into source code is a persistent and dangerous mistake, and it comes in two flavors. The first is a hidden maintenance account, a backdoor the developer adds to regain access if authentication fails. If that backdoor password ever leaks, every deployed copy of the code is compromised at once. The second is embedding credentials for other services right in the code. So if the code is disclosed, those secrets go with it. This happens all too often when developers accidentally push code-holding keys or passwords into a public repository. The fix is to keep secrets out of source entirely, using secure configuration and secret management instead. Picture writing the master keys combination directly on the lock for anyone to read. What risks come with AI-assisted coding? As developers lean on artificial intelligence to write code faster, new hazards appear. These tools can hallucinate, confidently suggesting libraries, functions, or interfaces that do not actually exist or behave nothing like expected. Worse, because they learn from vast amounts of public code, they can quietly recommend insecure snippets carrying known vulnerabilities, outdated functions, or subtle logic errors. Speed is seductive, but blind trust is dangerous. The discipline is unchanged from any other borrowed code. Critically review, independently verify, and thoroughly test everything the AI produces before it ships. Think of a fast but unproven intern whose work you always check before it reaches a customer. How does poor memory management undermine security? When applications manage their own memory, careless handling can cripple the whole system, and two problems stand out. The first is resource exhaustion, where a system consumes all its memory, storage, or processing until it grinds to a halt. A classic cause is a memory leak, where an application keeps requesting memory and forgets to return what it no longer needs, slowly starving the machine until it crashes. The second is pointer dereferencing gone wrong. A pointer holds the address of data elsewhere in memory, and following it is normal. But if the pointer is empty, a null value, dereferencing it triggers a null pointer exception. At best, the program crashes and hands an attacker useful debugging clues, and at worst, it lets them bypass security controls entirely. Security professionals should partner with developers to catch these issues early. Picture a warehouse that keeps taking in stock but never ships any out, until the aisles are so jammed nothing can move. So let's bring it together, and with it, our entire journey through the CISSP domains. Comments help developers, but must never leak to the public. Error handling anticipates the unexpected and hides its inner workings while logging the details. Hard-coded credentials, whether backdoors or embedded secrets, must stay out of source code entirely. AI-assisted coding demands the same critical review as any borrowed code. And sound memory management prevents exhaustion and null pointer failures. Secure coding is where every principle in this series finally meets the keyboard. Carry these habits forward, and you carry the whole discipline with you. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I wish you all the very best with your CISSP examination preparation.